Ladies and gentlemen, ones and zeros. I come to you from Idaho National Laboratory, and for the next, let's see, we are way over time. So what's that? No, we're gonna make it quicker. Fire away. So I've got some slides up here about INL, some of the laboratory things and stuff. I'm gonna move through those very quickly so we can get to the demonstrations. How about we do that? So for the next, I don't know, 10, 20 minutes, I'm gonna welcome you into my world of project management at Idaho National Laboratory. So we are one of 17 labs in the DOE complex, the lead nuclear energy lab, but we're not here to talk about that. We're here to talk about industrial control systems and cybersecurity, which we've been doing for quite a while. We have a vast area in Idaho, 890 square miles. We have a big test range, test loop. We have nuclear power plants. We have transmission lines that go into a big loop, so we can actually do large scale testing with critical infrastructure. And if you see something on the slides you want to talk about later, just come find me after, because I'm going to skip a lot of the thoughts there. I am part of the workforce development and training office within the National and Homeland Security Division at INL. So I don't do the nuclear research and development. I focus in on national and homeland security. That involves cybersecurity for critical infrastructure. As you can see here, yes. So laboratories are designed to be these innovative, just doing a lot of research, development, and experimentation that industry or universities can't or maybe shouldn't do. And one of those areas is ICS. My first job at INL, so I left the Pentagon in 2009 to come to Idaho National Laboratory, and we were just starting to build the Industrial Control Systems Cyber Emergency Response Team, ICS CERT, which has evolved over time, now is the CISA agency. So that's where I got my feet wet at INL within the industrial control systems and cybersecurity. And now I do a lot of training. Department of Energy, Department of Homeland Security, they come to INL and they say, we need to train our critical infrastructure owners and operators on industrial control system cybersecurity. There are some aspects that you guys can do very uniquely. So we build equipment like this. And I want to give a shout out to our rapid prototyping folks, because they are the ones who have built all of this equipment. They have all kinds of CNC lathes and milling machinery and PCB design and all of this stuff. And so they can take a CAD model like this, which is a design for a training box that we're hoping to build. So we've pitched this to DOE for the renewable sector. We've been focused in on electric sector, oil and gas sector, water sector, and now we want to touch in on renewables. And so in this box, we've got a little wind turbine and a little Tesla truck and a dual axis tracker. And we want to be able to put this in front of a student and say, okay, you can go in and make affect these devices through cyber means. Okay. So I think that's enough about all that. Little arc flash. This is my friend, little arc flash on the left here. And what we're looking at is, let's see if I can display this. So this was built at INL for DHS. And can you see the? No, I need to somehow share the other screen. Let's back out of that and over to here. Yes, that's working. Okay. So guys, I've got a camera, because I know this may be hard for you to see. This is going to get shaky for a minute. But here is the panel. Okay, so we've got 3 different types of generation. Okay, electric generation. Coal, nuclear, hydro. Generation usually goes through the transmission system, so it's going to step up through a big transformer and then step back down through a transformer into the distribution. So what we're showing up here is we've got, okay, hydro generation is going through this transmission system here down into a residential neighborhood. Okay, and now we're going to transition to the neighborhood. Hello, neighborhood. I feel like Mr. Rogers for a moment. Okay, hopefully this gets really steady for you. Okay, so neighborhood, what you're gonna see is we're gonna turn this tie breaker on here. And here's our transformer in the corner. And we can power up this little neighborhood. This is all touch screen. So I'm gonna work up here. So red is hot, red is energized, which means we just gotta close this breaker here. And close, and then close. Why isn't that going away? And here. Okay, so now you see the power to the little city. We're gonna open this breaker. Open this breaker. Come on. Okay. So the power is now off, and we've turned the power off because what we're going to show here is that when you are trying to perform maintenance on a transformer like this, what's going to happen is with the control panel, this HMI, they can go in and they can set a maintenance block on this transformer so that they know not to energize it, right? And so we're going to set a maintenance block, and I'm going to have to camera up again. Let's get real close. So we're going to put a maintenance block on right here, and you see that little MB? You can't see it. That's all right. There's a little MB. It says maintenance block, right? And you can come up afterward, and we can do this whole experiment again. It's actually pretty quick once we do the maintenance block. So we've got the maintenance block, and then that opens up the circuit, so there's no more power flowing. But let's say within this distribution company that somebody has clicked on a spearfish with a PDF with a malicious exploit, and an attacker, remote cyber attacker, has gained administrative privileges. They have traversed the network, and now they're in the operational side, and they can access this HMI. Let's say that we're in that situation. And so there is maintenance happening on the transformer, and what they're going to do, even though there's a maintenance block, they're going to override that, and they're going to close the breaker. Ooh. Lost a video. Can't lose video. Okay, so they're going to close the breaker, and during a maintenance work, if they close that breaker, energize the system, okay, lights are going to go on for just a minute, but it could be hazardous, like potentially like transformer's going to arc and perhaps even, get destroyed. So let's see what happens. So we've got the maintenance block on. We're going to close the breaker. And we're going to close that breaker. And we're going to close that breaker. So the lights are now on. Let's cross our fingers. Yikes. Let's see. Can you see the smoke? There's smoke. Should we do it again? Let's see if we can see the smoke. That's really the whole demo for this system. Let's get right up close. Smoke coming through? A little bit, you can see it, right? Well, you can come up after and we can do that again because it's super simple. That's this, okay? Just designed to show some effect. Okay, this is what could happen. It's really just a show, a toy, right? It's a great way to get interest in this kind of cybersecurity work that we do. Okay, so we're going to move on to the other demo. Now I've had this system running. It's just been kind of pumping. Hopefully you can still hear me over the noise. We're going to close that down and we're going to look at oil and gas separation. 5 keys. I've gone back to the beginning, bad PowerPoint skills. Okay, gas oil separation. Anybody here understand the gas oil separation process? Yeah, okay, a few of you. So very simply, we've got a diagram here. So the product comes in from the wellhead, right? Goes into a tank and it's going to contain oil and water and gas. And so we put it in this tank and we have different valves. So oil and water don't mix, so we can separate those out, and then gas is going to rise up to the top above that. And so we can filter these, separate these products just by diverting them at different times and after different periods. So that's the really simple version, okay? And we said, okay, well, we want to show some of the possibilities that a cyber attack can cause with, let's say, gas oil separation. But we don't have a wellhead that we can just carry around, right? And so what we did, and what you'll see here are 2 tanks. The tank on the left is going to be our wellhead, so it's our supply. So just pretend that that's big pipeline coming in to our separator. So the one on the right is the separator unit. And the separator unit, this was built as part of our CyberStrike workshop. Uber Eats is telling me it's time to order dinner. This is built for the CyberStrike workshop for the Department of Energy. And it's something that we go to utilities and we sit them down. We take the operators, their IT guys, we put them together and we walk them through, this is how a cyber attack happens. This is what the adversaries are doing, from open source reconnaissance all the way to impacting the operations. And when they sit down at the keyboard, these operators, and they perform the attacks, and they start to understand, oh, this isn't magic. And so here's what we have. Okay, this says demonstration, so it's time. Okay. So we have this unit, and let's say again, we've got somebody who has gotten access on the network. I had to reboot my computer so to get the display to work, so I've got to relog into my virtual machine. So apologies, I'll try to talk while it's doing it. But we've got an attacker, could be anywhere in the world. They've gained access to the network. They've, through privilege escalation, whatever, they've gotten their ability to traverse the network, get down into the OT systems, and we say, okay, well, what can you do once you have access? A lot of us know they can do a lot of things. We've seen some of the examples of things they can do. So what we're going to do with this, okay, we've just got some pumps, valves, pressure valve, level valve, pumps, product pumps to get the material in and out. And so when we can take control of those things, any ideas on a bad scenario we could do? Thoughts? Yeah. Gas blow by? I don't know. Perhaps. What about with the pumps specifically? Something bad we could do with the pump? Yes? So you're talking about cycling it back and forth, bringing it out of phase through the electricity, maybe. So we're going to go very simple, and we are going to deadhead the pump. Anybody know when you deadhead a pump? So deadheading a pump is making that pump spin, but it's not able to push the product through the line because it's blocked. And so you imagine this oil coming in, this pump is spinning it through the line, and it's over 100 degrees coming in already. And that pump's just spinning, right? Trying to push the fluid, but it can't. But it keeps going. It's called a deadhead. And what happens is it starts to heat the product and heat it because it's still spinning, and it turns into a vapor. You can have explosions. You can have the pump, all the materials inside the pump crack and break, and it's a very bad scenario. You don't want to deadhead your pumps, but we're going to do it here. But before we get there, there's some other things we got to work up to. So we've got this process. We're going to go to, okay, this is an Allen Bradley HMI. And there are controls you can put in place on the Allen Bradley. So one of them is VNC, virtual network computing. You can turn that off if you'd like, but this one, it is turned on. So as a remote attacker, I can go in and say, okay, are we sharing this screen? Yes. Okay, so if I have VNC viewer, I can just go and now I have access. Okay. So if you have seen the cyberattack in Ukraine, the video that's on YouTube 2015, going way back, right? The attackers, this is what they did. They just took control of the operator workstation, HMI, and just opened breakers. So I can do that. I can just do an emergency stop right now from wherever I am, because this port 5900 VNC is open. And I just connect, there's no authentication. So we've got control of the system through the operator workstation. That's one attack. Just using the tools that are available for the engineers. But let's say we want to do something a little more nefarious. So another thing we can do, and guys, I'm the project manager. I'm not the cyber guy developing these things. They've taught me enough that I can hopefully convey them to you, but I'm not the guy. I asked around, who wants to go to Orlando and do this presentation? I couldn't get any takers. But I grew up in Florida, so I'm happy to be here. Even if it's not, the best, we'll still be able to convey what we're trying to do. Okay. So, oh no, I wanted Wireshark. So Wireshark, yes. Users of Wireshark. There we go. Now we're getting somewhere. Okay, a lot of hands. Okay, if I'm on this network and I open Wireshark, I should be able to see the traffic, right? So we're gonna do that. We're gonna go, and you guys may have to help me, but this is our interface. And I want to find SIP traffic. So we're talking Ethernet IP SIP, Common Industrial Protocol, because that's what these two devices are talking. So we've got this big PLC, and after we're done, won't be too much longer. You can come up here and you can touch this device. This is a touch screen. You can open the valves, close the valves. Okay. You can come do all this. I am happy for you to come and touch the equipment. But to read the traffic between the PLC and the HMI, it's SIP traffic, so we've got to be able to read it. But this is Wireshark, let's capture. Oh, we're restart. I'm not seeing anything, right? So that's because it's I'm only going to be able to see the traffic that is broadcast to everybody or multicast, right? But that's not the case with this. So we have to go and insert ourselves. What have I done? We have to insert ourselves into this traffic flow. And we're going to use a tool called EtterCap. Okay, let's go back. And I've got these already. Okay, so we're going to use EtterCap, and we're going to do ARP poisoning. We're going to insert ourselves and start. We're going to tell it to send us copies of all of this SIP data. So T EtterCap, we've got sudo EtterCap T. T is text-based, I is the interface, and M is the ARP poisoning. The IP address, which we could have gotten through some scanner, right? We've got the PLC is 150, HMI is 151. So we've got our argument built. Can I see the Wireshark? Okay, we're going to run this. And did it run? Oh, password. Uh-oh. Okay, now that's running, and okay, and so now we're flooded with this traffic. Okay, so I've still got my VNC viewer, I think. So that's not all. So we've got to, okay, because we're going to go in and we want to see exactly what traffic is tied, what commands are tied to these different operations. So if I open this this valve here, and I close it, and I open it, and I close it, and if I'm watching that traffic, can I pick that out? So we stop our capture, and we're going to go look for this traffic from the HMI to the PLC. We're going to look up IP, so Ethernet IP. We've filtered by SIP, and we've got the info status class 04C, 02B. Okay, so I am in the right area here. And you can see the highlighted packets down at the bottom, right? And what we're going to do is because I sat and I opened that valve and closed it, we can just watch this traffic for changes in the right areas, and through some through some trial and error, we can find the exact bit that command, that open valve, close valve command hits. And so when we find that, I need to scroll over. 602B04C, and I may have way too much traffic to dig through. But we can sit and watch that. And once we can see it, if we can capture it, then we can take that command. And we know that that's what the HMI is sending when I click it. So now we can just take that command, send it straight to the PLC, right? In the PLC, the SIP traffic, it's not requiring authentication. So I can replay that, and I can open that valve, close that valve from here without interfacing with the HMI. And so that's what we've done, because I'm not going to go through that whole process, but we find those bits, capture them, we put them into an EtterCap file, and then we can send them. So I've got the scripts already built. You can come up and see those later too if you want, but let's run them. Tab. So we've got this little Python script. And you can watch for the change on the screen that's not showing. Let's adjust the view just a little bit so you can see it. Come on. There we go. Minimize that one. Oh, and I can actually stop the other one. Okay, let's stop all this. Okay, so you can see this tank, you can see the separator, you can see what's happening. We're gonna quit this. Okay, so we don't need that anymore. And we've got our command, so we're gonna move this over. Apologize for having to kind of adjust on the fly here, but we're gonna set PV1, pressure valve 1. Let's make it 100. See what happens. Back over here. Okay. So now I'm making changes by sending these commands directly to the PLC. I could do it through VNC. I can make the change. And if I'm the operator watching the screen, that's probably what I'd do. Is I'd see something fishy happening. I'd want to fix it. But with control like this, we can make anything happen. And so let's go ahead and what's our fluid? Our tank level and our pressure is pretty low. So the numbers on the top, you see, those are pressures. That's our pressure levels. And on the HMI, you can see the inches and the pressure as well. So let's start this pump. I think that's number 3. Okay. Oh, you know what I didn't explain? Hold. I've got to run this. Okay. So in the auto mode, when we say, okay, we've got parameters, it's going to get, so we've got, let's say when the tank gets to this level, that's our max, and we want it to start draining. And this is just part of the process that they set in. We've got a low level, a high level, we've got a pressure we want to maintain. And so we set these parameters, we set the system to just run, and this is how it was going, right? So it was just running, operating, doing its separation process. So when we take control, we just muck around with everything. And if I am not an engineer, if I don't know the oil and gas system, that's what's going to happen. You're going to just muck around, right? But if you understand and you have a target that you want to cause, you can make the exact effect that you want to do. But the question is, you know, operators, they're going to see stuff happening, right? They're going to see what's going on. Well, there's another thing we can do, because we've captured, you know, we got in, we could look at all the SIP traffic, so we could capture all the data, right? So if I can capture what normal looks like, then I can maybe present that to the operator and kind of blind them to what I'm doing. So we've done that too. We took that script, and now we're going to spoof the operator workstation, because we've got that. Oh, am I still running that? Let's see. So now I'm spoofing. It looks like things are still working, right? But if you watch the actual physical equipment, you'll see that maybe it doesn't match up. Doesn't match up with what's actually happening. And so we can do a new tab, whoops, new tab, and we can run those scripts again and send commands directly to that. What's it at, 50%? Let's make it 100. Just changed it to 100. That's what's really happening, but you can't tell, right? So there's a lot of things that can happen, go on behind the scenes. This is something we try to present to operators cyber guys. When we go to utilities, we go to electric sector. We've got a similar platform with breakers and a fan. This one we do for oil and gas, water, all of those groups, because it's pumps and valves. Let's do another one. Let's do 3. So you see on the screen, still no change, right? But we're just able to go in and make some changes on the fly. New value. It's not working. And we can even go back to our full screen. We can do an emergency stop. All red lights, but look, it's like it's still running. So we can go back over and we can quit this. And then the screen returns to normal. So it's just pulling. This HMI is just pulling data from the PLC and then showing it on the screen. And so through that machine in the middle attack, what we did is we just sent our own data faster than it could pull, so that it now displays what we tell it to display rather than what's actual. And so once we quit that attack, the next pull cycle shows the reality. And so this is our situation, and we can go in and we can start, messing around with everything, and we can start this pump. Get flow going. Okay, so you can follow the arrows to kind of see where things are going. We're getting some pressure buildup, right? Get some flow there. 12 psi. Are we over 13 psi? So this system does have pressure relief valves, but not until about 23 psi. And it's in like double tanked, like double encased because of safety for the lab and such. So, but we're at 14 psi. So I should be able to, let's see, let's run pump 2. So we're running pump 2 100%. And we're going to line up PV2. Excuse him. Okay. So we've got PV2 running full speed over here. We've got this level valve at 0, pressure at 12. Are we moving fluid? Ooh, you hear that? Okay, so bad things are happening right now. And if I was still spoofing that screen, they'd be none the wiser, right? So this is our situation. Yeah, it's really pushing the pressure up. Okay, so let's stop it. I don't want to cause any problems. What are we at? I'm way over. At least over what I thought I'd be, Tim. So that's the demos. Hope it was useful. Please come up. Please come see the systems, come see the equipment. Our guys in Idaho, they work hard to build these, and it's pretty fun. And that's it. So thank you.